So in this question here, we see what looks like to be which looks to be the ground down here, and an object coming in like this, hitting the ground and bouncing off like so. We see these two angles, which are depicted as theta 0 and theta 0, which seems to indicate that they are the same as each other. We're given the positive x direction is over here. This is positive x and this is positive y. So just looking at this question without any background information, we could start applying different concepts we know to this. So we could first start out with kinematics. And the most important concepts for us there are to look at the velocity and the acceleration. And so if we are to look at this velocity, see before the bounce, it would be traveling at constant velocity. And a velocity is a vector. So we have a velocity vector like this in this direction. And so that's v0. And then afterward, we have a velocity like so. Now it looks like, and we should expect, that these two velocities would be the same. But this is v, and that's v0. Now velocity has magnitude and direction. So if they are the same speed, they have the same magnitude, but the direction is different. So therefore, there is acceleration. So that's something for us to note. The next concept we could apply would be momentum, especially since there is a collision going on. And we apply the momentum, and so we have beforehand in blue, we have momentum like this, which would behave exactly the same as the velocity, except it would just be multiplied by the mass, so it would be scaled by the mass. And afterward, we have the final momentum, like so, which would also be scaled like the mass. And if the speeds are the same, that means the momentum would be the same in magnitude. So the magnitudes would be equal, but the direction is different. So that means there is a delta P, which is going to be related to m delta v. And if there's a delta v, we know there's an acceleration, and if there is an observed acceleration, there's a net force. And F net is defined as the rate of change of momentum, delta P over delta T. So there's a number of things that we see there. Now, this is a two-dimensional problem, so we might also now break the momentum into vectors to understand the changes a little better. So we have, for the afterward P, we have Px, and we have Py. And for the momentum before, we have Py and Px, like so. And that's a way for us to see that if v and v0 are equal, then Px would be equal and the same direction, and Py would be equal and opposite to each other. So if all of those things is true, we've now kind of come up with an understanding of what's going on here, that the change in momentum is due to the interactive force, the action-interaction pair with the ball and the wall, the ground, and so forth. So let's read the question now that we've fleshed out and have an understanding of what's going on. So ball is thrown toward the ground. We were right. The direction of the ball before it reaches the ground and the direction after it bounces off the ground. Good. The ball leaves the ground with the same speed, so our assumption was correct. V equals V0 in magnitude. The angle before and after the ball is the same. Is theta 0 before and after, so that was correct, our interpretation of that. And the positive angles are indicated. So all of our analysis beforehand is correct. Each grid represents the component of the change in momentum the ball as a result of the bounce. Draw a vector to indicate the direction and relative magnitude of the ball as a result of the bounce. If there is no change in momentum, write no change. Well, we have already seen that, if we do the delta p x, or the delta p x is going to be p0 or px minus p0x, and we said they are exactly the same direction, same size, so delta px is 0. There is no change in x. Now, when it comes to the vertical, delta py is py minus p0y. And so let's draw those out. We have py like so. And if we were to add P0y, P0y looks like this. So if we added them, P0y plus Py, we would get 0. But what we're really doing is we're taking Py and adding a negative P0y. And what the negative means is it's the opposite direction. So if we drew a negative P0y, that would be this, negative P0y. So the simplest solution for us to write this would be delta Py. But we can see what that's based off is a Py plus a negative P0y, leading to that Py. You know, and maybe if we wanted to, so that we're afraid of them being, having all the algebra beneath would not make it confusing to a rater. But we could also do this dotted and label it Py and minus P0y. And that would actually make it clear exactly what we're trying to show there. So when we look at the scoring, we see no change in the horizontal, upward arrow for the vertical component of the ball. And so they just chose an arbitrary length to do that, but we're actually giving a little bit more. This is completely satisfactory to answer the question.